everybody, Harold here. The second of my Tidyr videos. This one's going to be about pivoting in Tidyr. So let's load the necessary libraries. We'll need tidyverse, recursive for some of the data sets I'm going to use, and GT extras to make nice tables for presenting our data. So pivoting is about how people want to view or use the data for analysis. So you'll get them in a wide form or a long form. I want to start with pivot longer. So we're going to get some data and get it into tidy form by pivoting longer. So let's load the libraries. Now I'm going to create a data frame called teams, team red, blue, green, purple, and orange. And their scores for rounds A, B, C, D, and E. So here's my data frame, teams, and the column for their scores for each round. Now, this is a common form people might use for data entry, like a scorecard. It's easy to see the score each team got in each round, but I can't sort it by round or anything like that because it's in this wide format. So we need to get it in a tidy format. And to do that, we need one column for round and one for score. Make it tidy. And definition of tidy is every row is an observation. Every observation is a row. Every variable is a column. Every column is a variable. And every cell has a single value. Well, teams rounds is a variable, but it doesn't have its own column. And scores is in more than one column. And we want it in one column, be tidy. So we could say scores, pivot longer. And the arguments here are you have to tell it what columns you want to pivot A, B, C, D, E, and E. I could have said A colon E. Then you have to tell it the name of the column you want the column headers to go to. So round should be a column with A, B, C, D, and E in it. Then you need to tell it the name of the column you want the values to go to. We're going to call that score. And we're going to say also drop na, values drop na. If there's any NAs, drop them. Values drop na equals true. So let's see what that does. Now, see we have teams, round, and score. Red, 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 A, B, C, D, E, score, 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 score. Same with blue and green, etc. So now we can sort, filter, what have you, with each variable in its own column. So that's pivot longer. That's a simple example. Let me expand on that Game of Thrones characters example from my nesting video to show you a little bit more of this on longer. So got chars is a list of lists of all the characters in Game of Thrones, their titles, spouse died, mother, father, etc. It is not in any kind of tidy format we can use. I showed you in my last video how we could unnest that. So we make a tibble, say char equals dot chars. Then we're going to unnest that wider. And let me show you that at that point it's this. So we've now unnested into columns, but We wanted to see titles. We'll take this. We'll unnest the titles wider. So we'll have a column for each title. The sep gives a distinct column name. Then I'm just going to select name and the columns that starts with title. Then I'm going to pivot those longer. The columns will start with title. The names to a column called precedence. So title 1, title 2, title 3 will be precedence. Values to a column called title, which will be the names of the titles, and we'll do our drop not equals true. And then I did a little cleaning. I'm going to change precedence to replace titles with title, just to clean it up a little, and then to put in a little table with my GT theme ESPN. So let's see what that looks like. So now we've unnested titles wider and then pivoted them longer. So Theon is title 1, Prince of Winterfell. Title 2, Lord of the Iron Islands. So on for Tyrion, Daenerys, her 5, Davos, Seaworth, etc., etc. So we've pivoted longer for exploratory data analysis. Now, sometimes people want to see the actual form it was entered in or see it in a format wider. And at that point, we need to untidy our data, comply with requests for a specific format. So let's take our scores data frame back to the wide format. So first we'll commit it to longer. So scores L equals scores, pipe in that in to pivot longer, A, B, C, D, E, names to round, values to score, drop not equals true. This is what we did before. Now take that, just show you scores L. So that's our long form. We want to get it wide, so scores W equals scores long L, and then we're going to pivot that wider. And instead of names to and values to, we're going to take names from the round. So it'll pick out each unique value in the round and make it a column. And values from the score, each score value associated with the, say, round A will be under A. So let's run that. Take a look at it. So now uh, we have the wide format. Again, we started with teams, column for teams, and a column for each round with the scores under each round. So that's how you pivot wider. Let's try another one. There's a database included in the Tidyverse called Orange. It's just a list of trees, how old they are when they were measured, and their circumference. That's tree 1 through 5. They're all measured at the same ages, 118, 484, 864, 1000. So that keeps repeating. So Orange is tidy for EDA, but someone wanted to show a comparison of circumference of each tree at each age observation. It's kind of hard to see that in this format, so we need to pivot wider. So I can say orange, pivot wider, names from tree. So I want a column for each tree, values from circumference, which will leave age as its own column. So let's just show you that. So now at each age range, each tree has observation. So I can quickly say at age 118, tree 2 was the largest, and trees 1, 3, and 4 were the smallest, so on and so forth. I could look at that. So that's why we would want to pivot wider. Another thing with you can do here is use values function, which lets you use aggregators and list and unnest items. So I'm going to make I'm going to set a random seed for reproducibility. If you run this, you should get the same random numbers I do. Then I'll make a vector per test. It repeats 1, 2, 3, 6 times. Vector for points. That random numbers, 18 random numbers between 10 and 20. And a vector for students. 3 students repeated 3 times. And I'm going to make that into a data frame called pivot test. And let's look at that. So here's our a tidy format. And what we've got here, the problem is for each test, each student took it 3 times. So there's multiple observations for each test. So these aren't unique. These aren't unique. And these are. Well, they're not unique, but these scores pertain to that specific test. So what we can do here is, well, if we try to pivot this wider, just take this out real quick. Values from points are not uniquely identified. Output will contain list columns. Use values function list to suppress this warning. Use values function aggregate or summary function to summarize duplicates, or use the following dplyr. We're going to do the first 2 suggestions. So let me put back in values function equals sum. And what that's going to do is sum the values for each test for each student. If that's not what you wanted, you can use the other aggregators. So mean, it's a mean for each student. The median score for each student. And if you can't guess already, we can do the max score for each student, for each test, and the min. And if we just wanted to see all the scores for each student, we can list and unnest. So a pivot test is pivot wider, names from student, values from points. And the values function here is list. And once you get that, let's see if we can run that by itself. So that's a test column with 2 list column with the scores for A and B. Of course, if you go back to our nest function, we can unnest those wider and get a look at them. So let's run the whole thing. Test A1, A2, A3. Test 1, student 1, first, second, and third attempts, then their scores, unnested wider. So that's how you use pivot, pivot longer, pivot wider. I hope you liked this one. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.